making my way downtown, walking fast, faces pass, I'm homebound. Okay, let's get down to business. As you just saw, I was sitting on a skateboard representing Newton's first law. Newton's first law states that an object at rest will stay at rest unless acted upon by an outside force. In this free body diagram, this dot in the middle represents me sitting on the skateboard. My weight, which is the gravitational force, is pushing down against the skateboard, and the skateboard is pushing back up against me with the normal force. Since both forces are balanced, they will cancel each other out, making the net force equal 0.
Newton's first law also explains that an object in motion will tend to stay in motion unless acted upon by an outside force. As you saw in the previous example, Danny was riding a skateboard at a constant speed. In this free body diagram, all the forces acting on Danny are balanced, therefore the net force is 0.
Newton's first law also represents that an object that is speeding up or slowing down has other forces acting upon it, making it unbalanced. In the previous example, I got hit by a car and it really hurted. In this free body diagram, it represents me getting hit by a car. I was going at a constant speed, but then the car hit me, making me slow down, making the forces unbalanced, and then making the net force not equal to 0. Newton's second law states that net force equals mass times acceleration. Force and acceleration are directly proportional, while mass and acceleration are inversely proportional.
As you saw in the previous example, when we increased the force and the push, the boxes flew much further. When we increased the mass of the object substantially, the object didn't move as much.
When I push the two half-kilogram boxes with a 5 Newton force, the acceleration is 10 meters per second squared. But when I increase my force, the acceleration increases to 20 meters per second squared.
When the mass increases to 65 kilograms, it will become harder to push, therefore the acceleration decreases.
Newton's third law states that for every force, there's an equal force in the opposite direction.
Go.
So this is Newton's first law.